All right, so we're starting chapter 1 here, and we're still dealing with trig equations and trig functions. So we're going to go through a little bit about what we're doing here. So 8.1 is solving simple trig equations. So these are simple to solve, but here's the problem, and here's where I guarantee that you guys are going to struggle a little bit. It is very important for us to pay attention to this right here, which is first of all, it's the interval that we're dealing with, but it also tells you what the interval is going to be in. So right away, we see that this interval is in radians because we're dealing with pi's. Okay, so we want to make sure that when we solve this equation that we are in radians. So you want to make sure the mode of the calculator is in radians. The first thing we want to talk about here is how do we solve an equation like this? Well, it's real simple. Because we have sine of theta equal to something, to solve it, we can just use the inverse sine of 0.254, and that will be equal to theta. Now, as easy as this sounds, it is easy at first, okay? So what we're looking at here is we have theta is equal to 0.257 radians. But here's the problem. This is what your calculator will give you because it's only defined over a certain interval dealing with inverse sine. So that is one of our answers, but keep in mind we want to know the interval from negative 2 pi to pi. Now, if you recall, hopefully you do, a sine graph looks like this. Okay, now, what does that mean? Well, if you recall here, this is 0, this right here is pi, this is 2 pi. This over here is going to be negative pi, and this over here is going to be negative 2 pi. The reason why this becomes an issue is if you think about where our sine graph is equal to 0.254, we know the top point is 1, we know the bottom point is negative 1. So 0.254 is going to be, say, at this point right here, okay? But it's also going to be at this point right here. And it's also going to be at this point over here, and it's also going to be at this point over here. So when we're dealing with an interval from negative 2 pi all the way to 2 pi, we have 4 places where it's going to be equal to 0.254. So we need to figure out, how do we figure out where else it's going to be? So the 0.257 is for sure going to be this point right here. That's our 0.257. So the question is how do we figure out what this point is right here? Well, it's actually pretty simple if you think about it. 0.257 on the unit circle, that would be what our reference angle is. So if I do the unit circle and I go up 0.257, that is what our reference angle is. That's the 0.257, okay? When I go to the other side, if I keep going right before pi, it's going to be a line that looks like this, and this angle is still going to be 0.257. So in reality, to figure out what the actual radians are there, and this is where it's, you have to remember how radians work, we've got to figure out what it would be all the way until this line. Well, that is figured out by just simply doing pi minus 0.257. So our second point would be, this right here would be pi minus 0.257. Okay, so now once we do that, we'll get that value. That is 2.885 radians. Okay, so I did pi minus 0.257. That would give us the reference angle. Again, this is pi. We minus the 0.257 of the angle we know it's supposed to be, and that tells us what's left over there. Okay, so now what about these two? Well, these two are actually quite easy because we know that the period of a sine curve is 2 pi. So from this point right here, this red point to this red point is always going to be exactly 2 pi dealing with a function like this, which means that this point right here will be exactly 2 pi away. So what we can do is we can actually take 0.257 and minus 2 pi, okay, and we will get negative 6.026 radians. Okay, so that third point came from doing 2 pi, or sorry, I apologize, that's not right. we get that by doing 0.257 minus 2 pi, because we're going 2 pi in the left direction. Okay, and then the other one would be 2.885 minus 2 pi, and that would equal this down here. That was just left there on accident. So that's negative 3.398. Okay, so all four of these work. These are all in between negative 2 pi and 2 pi. But the point is, we start by using our inverse function to solve. So let's look at the next one. Very, very similar idea here. Okay, we have the cosine of theta equals negative 7.757. But here, the first thing we want to notice here is that this one is in degrees. So we want to make sure that our calculator is in degree mode. Okay, so that's degrees. So again, let's do the same idea that we did before. We're going to do the inverse cosine. Okay, inverse cosine of negative 0.757 is equal to theta. So theta actually is equal to 139.2 degrees. Okay, so that's our initial amount. And again, let's look at a cosine graph. The cosine graph always starts up top. Okay, and then goes down. Okay, so the point is here is that this is 0, this right here, sorry about that, this is 2 pi, well here, sorry, let me erase this because we are in degrees, so that's 180 degrees, that's 360 degrees, that's negative 180 degrees, and that's negative 360 degrees. So again, think about where negative 0.757 would be. We're talking about it would be, you know, maybe, and it doesn't have to be exact, but maybe somewhere around here. Okay, so obviously it would be on both sides of these. So we know that this first one is going to be 139.2 degrees. So again, we need to figure out how do we get this point right here. Well, there's a couple ways you can do this. So if you think about your unit circle in this case, what's going to happen is if we go 139.2 degrees, we're going all the way to here, and then we get this reference angle right here. Okay? So this reference angle is going to be 180 minus 139.2. So we do 180 minus 139.2 to get that reference angle, and that ends up being 40.8 degrees. Why is that important? Well, here's the reason why that's important is if I know that this is 40.8 degrees for my reference angle, then I know that when I go to the other place, I know that that reference angle has to be the exact same thing. It's got to be 40.8. So to figure out what the full degrees would be is going to be 180 plus 40.8, and that is equal to 220.8 degrees. So that's going to be our other value, 220.8 degrees. That's how you figure this out. When you draw it out on a graph, I see that I go 139.2 degrees, I get to 180, well then I'm going the exact same distance in this direction that I did in this direction. So what I was doing was I was figuring out what is the distance between here and here, okay? So, excuse me. So the distance is the same. So it was 40.8, so I just added 40.8 to 180 and got 220. Now, the same thing is going to be done to figure out what the other two. We've got to figure out what the negatives are. So we can just simply do 139, 139.2 minus 360. It's going to be the same thing, okay? And what you will find is with a cosine graph, they end up being the exact opposite. So 139.2 minus 360 would be negative, we're going to get negative 139.2 because it's cosine, it's going to be complete opposite, and then we're also going to get negative 220.8. Okay, so those are the two other values that we're going to get. So we have 4 values here. Okay, now this is all if they give you bounds. Okay, if they give you bounds, in my mind, it's actually a lot harder. But if they don't give you bounds, we need to know how to write the answer because obviously they will repeat forever. Sine of theta is going to equal 0.254 forever if there's no bounds. So here's what's really easy about this is we've already discovered that the inverse sine is going to be 0.257. Okay, so it's already going to be 0.257. So what do we do from there? Well, it's real simple. We know that every 2 pi or negative 2 pi from that, okay, it's going to be 0.257 again. So what we will do is we will add 2 times n times pi. Okay? The other one, which was 2.885, we will also add 2 times n times pi to that as well. So again, we have both of our initial values that we had, and then all we're doing is adding 2n pi. So n can be a negative, and that would go in reverse. It could be positive. Basically, what that's doing is every 2 pi after that or every 2 pi before that, we're going to get a solution. Okay? So with the cosine, it's the exact same thing, okay? Except in this case, we're going to do it in degrees. So we take our values, we have 139.2, and that will be plus 360n. And then we take the 220.8, and we're just going to add 360n. Again, all that means is that we're adding or subtracting any multiple of 360 degrees, and that's what theta would equal for it to be negative 0.757 again. Okay? All right, so what I'm going to do is, this is probably going to have to go into a second video, and I'd rather us not get cut off. So I'm just going to cut it off right here, but don't forget to move on to part 2 of the video right now. And like I said, we'll hopefully finish up this backside in about 5 to 7 minutes or so. We'll see how long it takes. Okay.